Hey, so I was bored this one evening this week, and I decided I was going to start doing some more MonoGame. So I started off playing with tiled shapes. I downloaded these assets from Kenny, um, and uh, he has a whole bunch of assets on here, and one of the ones caught my eye, which was miniature dungeons. I think I've probably gone past it now. Um, But I thought to myself, oh, that's interesting. I bet we could do an Atari clone. Is it this one? Oh, I can't remember now. One of the ones anyway. Maybe actually on page one. That's the one. Tiny Dungeon. Tiny Dungeon. Hold me closer, Tiny Dungeon. Anyway, so I thought, oh, that's a good sprite sheet. That'll make a good worthy attempt again at adventure, which I did using Unity, and you can see that video up there. This is uh, just a stream of consciousness of me programming uh, this particular game. So if you like streams of consciousness and you like watching people make video games, then this is for you. Uh, there is very little in the way of data in this game. It is mostly code. The only data file is in fact this sprite sheet, and that's it. Everything is done in code. So it's very hard coded. It's very uh, prescriptive, I guess is the word for it, maybe, where the even the backgrounds, it looks like it's a tiled map. It is not a tiled map. It is in fact completely and utterly faked. It uses random data, and it just places things where you think they should go. And each room has a particular seed value, and that's why every time you go into a room, the background has the same tiling as before because it's just faked. So if you like this sort of thing, continue watching, and if you don't, there'll be another jetpack video around soon. This is just a little bit of fun. I decided to test the waters and see what I could do with a kind of procedural-ish type map. So anyway, have fun. Let's see how we get on. Right, so after I downloaded that, I'm gonna copy this into here. This is the Kenny assets. So what I'm gonna do now is just set up just a simple sprite sheet that reads this in, the packed version of that tile map. And I'm not really gonna do much. I mean, there might not be a lot of talking in this, to be honest, but we'll see. So I can rename that sprite sheet, and I think this. What's the build one? Build. That's the one there. So it built that. So now I've got access to it inside here. So there's our game one. And then I'm going to have a sprite sheet here. So I'm going to add a new item. I call a sprite sheet. Public sprite sheet. 2D texture, and then we want cell width, cell height. Texture equals texture, cell width equals cell width, cell height equals cell height. Oops. Open there, and then just create read-only fields for these. And this one here. So that gives us our texture there, and then we can do public void draw, and then it's going to be int cell vector to position. Actually, Now I want to draw the sprite sheet at that point, so I actually want to pass in sprite sheet and be able to get the sprite sheet back. So I wanted. I do want to do this. I don't really want to. Oh, I never really thought. I got in here and started typing. So yeah, what I want to do is I want to have. I want to be able to draw something on the sprite sheet at a particular screen point. So I would have public. I mean, everything renders to texture, so it would be void draw sprite batch to position int cell ID. And then optionally we want color. So the optional color is white, but it's not going to let me do that. It's got to be a compile time constant. Equals null. Oh, that can't be null either. That can't be empty. Damn it. Do I have to pass in color? You know what? I know how to do that. Okay, well, right. You win. You win. What I'm going to have is public void draw. And this is going to have draw sprite batch, position, cell ID, white. And then here, what I'm going to do is the rectangle, source rectangle equals new rectangle, and then it is the cell ID. Now the cell ID is based on the X and Y coordinates. So if I grab this here, I don't know if you can see this, but roughly that is cell 0 up there, and that is cell, whatever this is, multiplied by whatever the number of cells is across here, multiplied by the number of cells down here. So I think it's like 12 across and 11 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yeah, so it's 12 across and 11 down. So 12 times 11 is, what's that, 132, something like that. So that's how many cells there are there. So if I want to do cell 0, I'm going to do this one, and so on. So our source rectangle, we need to do a wee bit of math in here. So our private read-only int cell columns rows. Well, it seems to know rows. So we can say the number of columns equals texture.width divided by cell width. And that gives us a number of columns, and our rows equals that. So that's worked out okay. So when we go back to our game, we load the content, we can say var SpriteSheet equals content.load texture 2D SpriteSheet. Actually, that would be texture. And then we can say var SpriteSheet equals new SpriteSheet. And then we pass in our texture. And then the cell width, which I think, thanks Bitdefender. What is the cell width? If I go to here, tile sheet, cancel. Oops. 16 by 16. Okay. So it is 16 by 16. So if I set a breakpoint here, run the game. Didn't like that. Okay, let's comment that out. Just now, run the game. Now we're going to step into this. So this should be there should be 12 tiles horizontally, which is the number of columns, and there should be 11 tiles vertically. So columns is 12, rows is 11, which is correct. And now to draw the sprite batch there, what we need to do is we need to figure out what the cell is. So our starting x coordinate is going to be equals the cell ID, and that we need to get that into the width. So that's going to be the divide. No, that's mod. Cell ID mod columns, and then var y equals that divided by rows, and that is going to be cell width times that, cell width, cell height times that. And then just to make sure, I'm sure bedmass works and all that kind of, or whatever it is, but just to make sure that's that there. And then our rectangle is going to be our x and our y and our cell width, cell height, and then we do sprite batch dot draw texture, and then it is our position, and then our source, and then our color, and that should draw the correct thing. So now if I change that to SpriteSheet, generate field SpriteSheet, there we go, and then inside here we do SpriteSheet, spritebatch.begin, spritebatch.end, because we've got to do that, spritebatch.draw, actually it's going to be spritesheet.draw, and then it's spritebatch, vector 2.0, and then cell ID, let's just do 0 just now, and that should draw a brown square. Boom, there we go, there is a brown square. That brown square looks a bit squished though, to me. Might be wrong, but it looks a bit squished. Let me see that. Yeah, it looks a bit squished. So cell width, cell height. Okay, maybe it's not. Okay, so that's going to be, let's have a look at this one here. So that's 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. So 7 times 12 is what, 84? Me. 84. Yeah, there we go. We've got our little wizard guy. Now I'm only going to make the screens 256 by 192, but I can't remember how to do that. Mono game scale screen. Scaling and zooming. How do we do this? Render time. So I'm sure there's a way to do it inside here, so I think you can do it. So when you create the graphic, graphics manager, you can do graphics dot preferred back buffer height is 192. Graphics dot preferred back buffer width equals 256. And I think that sets, yeah, there you go. That sets that. And then I think you can do graphics dot scale. No. Let me think about this. Where we got here? So set that to there. Set render target clear. Oh, okay. Okay, so if we wanted something that was, alright, okay, so we would do, let's see what they're doing there. So we want that to be, okay, KEU. We want that to be 1024 by 768 because we want it to be 4 times the size that we want to do it. And then they're saying that we have native render target is that. Okay, so we're going to have 192. So that's going to be 256, 192. And oh, see, that's not. Render target 2D. And then we do generate field that. And we say graphics device set render target. There we go. Device dot set render target. That there. We do all of that, and then at the very end we do native render target. Set render target. No. Okay, so let me do that there. This doesn't seem right, but okay. So once we've done that there, and then we do, can we just do this again? That doesn't seem right. And then what we're doing is we pass in, so sprite batch gets set there, and then this is going to be actual screen rectangle. Rectangle. I'm just going to do this just now. 0, 0, 1024, 768. And then this is, no, it doesn't like that. Sprite batch draw. Oh yeah, color. Okay. And that should get us off our back. So that should draw a big version of the screen. And it does. Sort of, kind of. It is 4 times the size of it, but preferred back buffer's off. Oh, height, that's why. Oh dear. Okay. All right, so we're drawing there. Now, I don't know if it's right, the fact that I'm drawing the back buffer twice using the same SpriteSheet. That seems a bit weird, the fact that I'm using that again. Seems kind of daft, but I'm wondering if we need to have our own sprite batch in there to render the scene. I'm going to leave it just now because I've got bigger fish to fry, I think. But what I'm going to do is I'm going to name all the sprites. I'm going to go off screen. I'm basically going to name all the sprites inside here. So that's going to be 84, 85, 86, 87, 88, 89, 90, 91, onwards. But I need to do that because it just makes things a little bit easier in the long run. Yeah, okay. I'm going to go do that, and I will see you in a sec. So I've got all these in here now, and I think that's pretty much all that I need to do. I've done a test, made sure things work okay. So now the thing I want to do is for the backgrounds, I want to have rooms. I need to map this out, but I just want to flood fill it with floor. So what I'm going to do is because it's 256 pixels across, which is 16 tiles across by 192 down, which is what is 192 divided by 16, which is 12, which means it's going to be, I fill in 10 rows because the top and bottom have to have a wall at the top of them, just because that's the way that I think Adventure works, if I remember rightly. So I'm gonna create some fill routines, just so that we can get those things in there. Now I'm probably gonna rewrite some of this stuff, but it's gonna be really super hard coded, this game. That's my goal anyway. So game one. So what I want to do is I want to have public private void draw sand int seed equals I know 210, I don't know, random dot seed. Can I seed that? Seed init. Can I not init it? Where's random? System random. So do I have, is there an XNA version of random? Microsoft.xna framework.random. There isn't? How do I seed? Seed generate for C#. Random constructor. Okay. Okay. So I do random equals new random seed. Okay. And that's how we succeed. So that gets us the random number, and then I want to say for int y. Actually, I need to pass in sprite batch sprite sheet. Y equals 0, or actually y equals 1, y less than 12, y plus plus, for int x equals 0, x less than 16, x plus plus, var x equals x. Actually, I don't need that. I can just pass that in. That's okay. And then I want to say what randomness is it? So var random equals random. Let's call percent equals random. Next single. Returns a random floating point number that's greater than 0, less than 1. Okay. So I want to say if PC is greater than 0.2, in other words, it's more than 80% of the time, it's just going to be sand. So I'm going to say int sand equals sprite dot sand. So actually I don't need to do that now, because if I'm setting that there, then I don't need to know it. So if PC is less than 10%, then sand equals sprites dot sand textured. And then I want to say else actually I want to have it as that, and I want that to be as few and far between as possible. So that's going to be sand equals sprites dot sand stones, and then I can do sheet draw sprite batch new vector 2 x times 16 y times 16, and then the cell ID is going to be sand. Okay. Why is it not liking that? Oh shoot, that's why. There we go. That's better. All right, so that's inside there, and then inside here, instead of that draw, I'm going to have draw sand, sprite batch, sprite sheet, and then the seed is just going to be 90210. That's fine. And this should draw the sand, top and bottom. Boom, there we go. Yeah. Less than 11. So that's going to draw that there. But it's still not. Well, the other thing as well is. Oh, okay. It is random. Not a great random seed. Let me change that a wee bit. 458. I don't know, just type in random numbers now. I think 456, that seems like a good random number. Okay, that's fine. Okay, so that is our randomness. Now we need walls either side of the, top and bottom. So we need a private void draw north wall, sprite batch, sheet, go has exit. So we're not going to worry about the has exit just now, but the north wall is basically going to be the exact same as the south wall. So let's just call it draw wall, and then we'll specify the y value. So the y value is going to be the offset of it. So int y offset. So you need to specify the y offset. And then the draw wall, we're going to say sheet.draw sprite batch new vector 2 0 long, and then the y offset times 16, because the y offset is going to be either 0 or 11. Let's make that 0 or 11 then. Bool is top. Var offset equals is top 0, 11 times 16. Whatever 11 times 16 is, I can't think of it just now. So we'll specify that as offset. And then we want to put in the cell ID, and the cell ID is going to be sprites.wall left. And then we're going to draw the rest of the wall. And then we're going to draw wall right. And that's going to be 14 times 16. Whatever 14 times 16 is, we can figure that out. So we're going to have in there. We have draw wall, sprite batch, sprite sheet, true, false. And then that's going to be false as well. So that's going to give us that. So we're a wee bit out there. That's going to be 15. That makes sense because that would be the end of the wall. And that puts our walls there. And then what else do we need to do? We need to draw the walls between that. So we need to do for int x equals 1, x less than 15, x plus plus. And then we're going to do dot wall. Boom. So now we should have walls. Boom. There we go. And then the next thing we need to do is we need to draw the exits. That's what we need to do. That's our next thing, is our exits. And our exits are slightly tricky. So we want to say if has exit and x is greater than, what would it be? So half of that would be 8. So greater than 7 and x is less than 8. Continue. Something like that. So let's change that to true. And we'll see what that does. Not a damn thing. It's greater than 7 and x is less than 8. Oh, less than 9. Okay, So that's got to be 6. Okay, that looks bang slap in the middle to me. And then we need to do our, we need to draw the door. So we want to say if has exit. We want to draw at 6. Whoa. Dot exit opening. What's it called? Opening left. Opening left. Opening right. That would be at 7. And we run it. And it's not quite right. Why is that not quite right? If has exit. That's like, first of all, that's the wrong door. So it should be 7 and 8. That's the wrong door. Opening right. Oh, I got that wrong. Where have I got that wrong? Opening left and opening right. Yeah, that's right. Opening left, opening right. So that would be 11, isn't it? And then that would be 9, 10, 11. 10, 11. That's right, isn't it? Why am I not seeing that? See, that looks like it's this one. I get 2 opening rights. Yeah, there's door opening right. Door opening right is 36, which is that one. And then the other one is door opened. But opening right is 11. It's 11. Let's put a breakpoint here. I'm sure this is 11. It's 11. Okay. And we go into here, and we say X and Y. So X is 176. Yeah, and Y is 16. So this Y is 16. We should put it there. Well, that is no good. Cell ID is 11. Cell ID 11. That's fine. There's your bug right there. All right, that'll work. But it did not work. Oh, that means they're all wrong then. What? They're all 12 out? Oh man. Gnarly, dude. So the wizard's out? That can't be right. No, it's not. There you go, wizard's there. Although annoyingly, he's over painting that. That's kind of strange, but that's minor. But okay, so the let's not get the fact that they're offset. Hold on one moment, please. So the wall left and wall right. So that's the wall right. So that's 48. I was right when I said 48. So that's 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58. So it's 58 wall right. Wall left, 58. And then that's 60. Where am I going? Here. Okay. Nope. Wait, what? Right, that's, oh no, hang on a minute, that's 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 57, 57, 57, 57, 57, and that would be 59, which would make sense because that would be the fifth row, and then that would make that 60. Okay, there we go, that's back. Right, so now the next problem is this down here, which needs to be rotated. So I need to factor that in. And I'm just going to be real hacky on this one. So I'm going to say int left equals sprites dot opening left, int right equals sprites dot opening right. Is top right is top left. Now you're probably thinking that seems a bit strange. So we're going to do left and right here. So now that's going to flip those two there. Now what that means is we can then flip it horizontally, the sprite. So if I go to here and I do draw, I can also do public void draw sprite batch vector I can do that there. It does mean I'm going to have to call that with the color, but I think that's okay. And then inside this draw, this has to have a flip of some kind. Rotation. Does sprite effect have it? No, I don't think it does. So I need to have flip vertical if flip float rotation equals flip vertical 90 or 0. So then I'm going to specify, oh dear, what happened there? Rotation is going to be rotation vector 2.0, scale is going to be 1, sprite effects dot, oh there it is there, flip vertically. So I'm going to put in 0 in here, 1 flip vertically, layer depth 0, I don't mind about that, and I'm going to say sprite effects effect equals none. Flip vertically. Sprite effects flip vertically or none. And I'm going to say that there. Okay. And then inside game 1, I can now do left or right. And then I can say is top. It's not is top, it's is bottom. Color white. And that's that there. Okay. So now if it's in the bottom, it will flip those two. I guess I don't need to switch them around. So let's do opening left, opening right. It's already going to do that for us. There we go. Okay. So now we have our exits top and bottom. And if we don't want them top and bottom, what we can do is we can just say, take that one away. And, oops. Oh, it needs to have as exit. That's fine. We can look at that. So that one's there. And then we can do false, true. Here we go. So now we get an exit there, and we're good to go. Okay. What else do we need to do here? Don't think we need to do anything else for this particular thing. We do need to have our player character. I think don't need sand there. Do we need sand? Okay. I mean, we could say sand equals that. Otherwise that. That gets rid of a couple of lines. Doesn't change anything, just gets rid of a couple of lines. That's okay. And then for this one, we really want to describe this room here. So draw sand is okay. I mean, every time we draw sand, it's going to be the same thing. So we need to have like a seed for each of these rooms so that they look slightly different. So that's a good thing. And then we need to know what exits there are. So if you are a wizard and you go north and south, which ones are there? We also need to have collision as well. So we need to know what to collide against, like if the wizard can collide against anything, or whatever your player is that you choose. And I think we can do that. So we can have our map. So our map's going to have a background on it. That's just going to be whatever the background is. Which is going to be random, and then it's going to have, do you have walls? And that's going to fill in the data for us, whether it's a collision detection or not. Okay. So I think that's the next thing to work out, and then pass that information into our renderer, our room renderer. So let's have a room renderer. So room renderer is just going to have we're just going to set the data in the room renderer and then let it render that information. So let's create one here. So add new item. Let's just call it renderer because it's the only thing that we're going to be rendering. Public renderer, sprite batch, sprite sheet, batch equals sprite batch, sprite equals sprite sheet, and of course make read-only fields for these things, like that. And then our draw wall and draw sand, they are now part of this. That there. Doesn't know what vector 2s are, so we're going to add that there. Public void draw room. Doesn't really matter what it is. And then the draw wall, we don't need that. Sprite sheet. Change. Well, that just didn't let me do that. That's not good. I'll just do it this way. And boom. There we go. And we don't need that for that either. Right, batch. Okay. That's that there. And then for our draw, what we're going to do is just take all of that out there and cheat just now and just have it as draw. Like that. Because we haven't set any of the data up yet. Get into it. Now once you've done that, we can do renderer equals new renderer, sprite batch, sprite sheet, and I'm going to generate a field there, and then do renderer dot draw. Okay, so that's going to render that, and now we need to pass in the room descriptor for it. So the room descriptor is going to be a little class that I like to call room descriptor. Boom, still got it. If you haven't already watched it, it is available on Disney Plus now, and it is fantastic. It is called Last Man on Earth, and it is amazing. Internal classroom descriptor, public bool. What do we got here? We need to draw walls top and bottom. We also need to draw walls top and side. Okay, so let's have a wall north, wall south. Oh, it's learning. And wall east. There we go. And we need to have public bool exit north, bool exit south, and if there's a wall if there's a wall to the west or east, that means there is no exit. The default is when we get to the edge of the screen, we check to see if the player has reached the edge of the screen, and if we have, then we move them to the next scene. Okay, so that's a room descriptor done there. Okay. I mean, the collision detection in here is going to be pretty basic as far as like room is concerned. So for the renderer, we need to do like void set description generate field that. And then for here, what we're going to do is draw wall, and then we want to do is top. So if description north wall, and we want to say description dot exit north, if description wall south, draw wall, exit south. Okay. And then inside our main game, we're going to set you off in the first room. So we need to set up our rooms. So we're going to have add new room, game map, public static, and I'm just going to create these in here. I know we should create a JSON file and all that kind of stuff, but I'm just going to put it in here just now. So this is going to be room descriptor first room equals new room descriptor exit north equals false, exit south equals false, wall north equals true, wall south equals true. And that's going to be our first room. So in game one, when we create a new renderer, I'm going to say renderer set description room, we want game map first room. There you go. You can't see fairer than that. And then that's going to set our first room, which is just going to be this room here. How do we move to next rooms? That's going to be a bit trickier. Although maybe not. I think the thing is we need an array of these, or we need maybe some kind of a map, like an actual map, like a dictionary, where we link these to one another, so we can do quick lookups. Yeah, I think we could probably do that in the static class, because there's like 20 rooms or something. There's not that many rooms. Get rid of that as well. Okay, let's get the wizard in, or the player, I should say. So the player That's going to be part of the renderer as well. So we just need to set the player's position. So the player, let's have a new item. Let's just call this player public vector 2 position get set public int player, let's just call it shape shaped shape get set. And we need to do that for the renderer as well. So inside our renderer we do set description public void set player equals player generate field player. That's that there. And then once that's done, we now have our player. So when we're in here, we want to draw the player on the screen. So we want to say SpriteSheet.draw sprite batch player.position player.shape. And our starting position is going to be sort of in the middle of the screen. In the middle of the screen, because it doesn't have to be accurately in the middle of the screen, but I guess we can put the player there. So inside our game, we can do renderer dot, we need to do player equals new player, position equals new vector 2, so that's going to be 128 and then 170, 187, 190, was that 96? 96, I think. And then shape equals sprites dot wizard. Okay. And then we do generate field player. Then we say renderer dot set player. Okay, so we've got our wizard in the middle of the screen. Now, our wizard, you'll notice, is not in the middle of the screen. So, we've got a couple of choices. We can move them up 8 pixels, which I'm going to do because it makes it a little bit easier for collision detection to say, okay, the wizard, the offset value is in the top left of the wizard. So I'm going to move it up 8 and move it back 8 here. So this is going to be 128, and then this is going to be 88, sorry. So that should put the wizard bang slap in the center of the screen, which looks like he is. And now, when we get update it, we're going to say keyboard state. Keyboard state, yeah. There you go. That's the one. If keyboard state dot is key down keys dot left. So if it's left, or keyboard state dot is key down keys dot A. So in other words, if they're going left, let's do vector 2 offset equals vector 2.0, offset plus equals new vector 2.1. There's no left. 2.left. There isn't. New vector 2. Let's see how big this is. I don't know how big it is. Else if blah blah blah. Where are we? Right. D new vector 2, and then it's going to be 1, 0, and this is going to be negative 1, 0. And then we want to say vector 2 new pause equals clear dot position plus offset dot position equals new pause. Now I'm doing it for this way for a reason, because to do collision detection in there. And I'm also going to set another one here called private room descriptor current room, and I'm going to say room equals game map dot first room current room, just to tidy it up a little bit. All right. So if we bring this in here, let's see. Okay, that's not too bad as far as speed's concerned. It's I can't remember exactly what it I think it's 50 frames a second or something. It clings onto XNA, so or 60 frames a second, I should say, because it's North America. So I think that's an okay-ish speed. I'm fine with that just now. And then we want to say if we want to repeat that all for the Y values. Up or it equals W. And then that's going to be 0, -1, because -1 is up the screen. And then this one is down, or S. Oh, darn it. Press the Windows key there, and now I've lost my position. I'm in the wrong file, that's why. And then this is going to be 0, 1. So now I've got my little sprite going, which is good. Now we need to stop him when he gets to walls. And the way we can do that is we can say if new pause is less than 16, less than 16, and room descriptor current room dot wall north new pause, it's dot y equals 16. There you go. So if we try and head up to the top of the screen, we should get blocked by the wall now because we have a wall. So boom, there we go. So that's just a simple check. It's just an integer value. We don't need to create collision detection meshes and God knows what else that you got to do. It's just we're saying you can't go further north than that. It gets a little bit more complicated when we put a door in, but it's very similar. And then we want to say else, else if new pause dot y is greater than, and then this is a wee bit tricky because I think it's 11 times 16. Again, we get these weird numbers here, so it's the 11th. Yeah, actually, it's going to be greater than 10, isn't it? And current room dot wall south new pause dot y equals 10 times 16. So this is going to clamp the player to the bottom wall. There we go. Okay. So now they can't move south because there's a wall there. And similarly, they can't move south because they can't move north because there's a wall there. Now, if we took that away, obviously that would mean they could move outside the bounds there. And there's nothing stopping the player moving out to the left and the right hand side because we want them to go that way because there's going to be something there. So when we detect that they're off the edge there, we need to figure out what room to go to when they hit that. So when they get to bonk there-ish, we want to find out what room to send them to next. And also we want to set their current position. So the current position is going to be some kind of offset, which is fine because we just need to offset it by whatever the screen is. So if they come off the left hand side, then they're going to appear in the right hand side, and that's going to give you the illusion of movement. Okay, so we need to have seed values for each of these rooms so that it looks like you're going into a different room. And the reason why we're using the seed values is because every time you use a seed value, which is that logic there, that comment, every time you have a seed value, then it means that every time you go into that room, it's going to be the same random number sequence that you get. So we're going to have public int seed is one of our things we put in here. And then inside game map, we're going to say seed equals 456, I think was the seed. Where's the renderer? Yeah, 456. So we're going to get rid of that seed there. And then we're going to pass in descriptor.seed. Okay. And our next room, we need to figure out where the exits are. So we're going to do yeah, we need to figure this out. We need to figure out the map of this, which I think is okay. I'm okay with the map. I think I've got an idea for the map. So inside a room descriptor, we'll get that, and then inside the where's the map? Game map. Here we go. We've got our static thing here, which is there, and then we've got public static dictionary, and then this is going to be int, and then it's going to be a room descriptor, and then this is going to have this is just going to be our map. So it's going to be game map.map equals new, and then first room is going to be 0 because the first room is always 0. And that's going to take you there, and then the second room is going to take you out there. So I need to have public int exit north, exit south. I kind of painted myself in the corner there. So rather than having exit north and exit south, let's have that as integers. And then default them to -1. And then we'll have public int exit west, public int exit east. Now, for fun, what I'm going to do is, so exit north and exit south, they don't have exits because they have walls, they don't have any exits. But it means that our our renderer is now broken because we're going to say exit north is greater than or equal to 0, greater than or equal to 0, and then that'll fix that. So if we are able to exit to the north, then we're going to allow for that to happen in there. Okay, and then for our game map, we don't need to put exit north, and exit south because they're false already just now. But I'm going to do exit east equals true. Oh, sorry, exit east equals 0, exit west equals 0. So what does that mean? It means that when we exit east or west, we go to the next room, which is the 0th room. So we're going to see some cool stuff here. Okay, it just means that we're going to basically put the player left or right. So we're going to say if new pause.x is less than 0, there can't be a brick wall there. Actually, it's going to be less than 16 and current room wall west new pause.x equals 16. Dot x is less than 0 and current room dot wall exit west is greater than equal to 0. But we also need to have else if new pause.x is greater than, and then it's going to be 15 times 16. Oops. So if it's on the right hand side of the screen, and current room dot wall east, we haven't even drawn the walls yet. New pause.x equals 15 times 16. So if that fails, that fails, that fails. So if it's x west is there, what we need to do is move rooms. So we want to find out what the exits are. So we want to say current room equals game map dot game map dot what am I thinking? Map, and then it's going to be current room dot exit west. So the current room is going to be that, and then I need to move the position new pause dot x equals 15 times 16. Else if new pause dot x is greater than 255 255. Actually, it's 256 minus. It's got to be -8, whatever that is. And current room dot that. It guesses really well. Visual Studio 2022. It's pretty good. Move rooms. And then for this one, I'm going to say, let's just move that to 1. Doesn't really matter. Exit east. Okay. What does this mean? Well, it means that if we move left or right from our position here, it should move us to the right or left position of the screen. So if I move off here, I should appear on the other side of the screen. There we go. And similarly, if I do that, it should appear on the other side of the screen. Perfect. That's exactly what we wanted. So our moving rooms work. It just so happens that we just don't have a moving room. So I'm going to create another room. And then let's see how this works. Okay. Okay. So let's have public static room descriptor east of first room equals new room descriptor. Wall north is true. Wall south equals true. Exit east is false, so I'm not going to set anything there, because if we go back to room descriptor, these are all set to -1. Exit west, it does take you back to 0. Seed equals 400. I don't know if that's true, but we also need to have exit south equals, and then this is going to be game map dot sword dragon chamber. Okay, and then we're going to have public static room descriptor sword dragon chamber equals new room descriptor. Oh, okay. Oh, exit south, sorry, exit south is not going to be that. It's going to be whatever the room descriptor is. So that's going to be first room, second room, 0, 1, that's going to be 2. Yeah, east of first room. Boom. I guess it. I've got to say, Visual Studio 2022, the developers of this clearly know my intention. Amazing, really good. Okay, and then for this one here, we're going to say there's no exit south, there's no exit, there's only exit north, and then we're exiting to east of first room. And then this can be 256 for the seed value. I hope this is making sense. So in our first room, we can exit east to the first room. We haven't got a west exit yet, so let's just leave it as that. We've got a wall north, wall south, we have an exit south and an exit west, and an exit south takes us to our sword dragon chamber. Okay, so if we head east of here, which is to the right as you're watching the screen, that should take us to a new screen that has no exit north but an exit south. And it did not. Okay. Our east exit is 1. Okay. So I'm going to do that there. So move over to the east. Okay. So east exit is 1. So our current room is that. And our current room now is 400. So we go back to game map. We do have that. Oh, but we're not setting the descriptor, that's why. What we need to do is we need to change the room. So I'm going to have a private void change room, new room, and then a renderer dot set description current room. There we go. Okay. And so I'm going to have change room in here instead of that. So it's just going to be change room, that, and then same thing here. There. Okay. Okay. So now when we go into here, it will be no exit north, exit south. There we go. And you'll see that the sand has changed as well. When we go back, you should notice that the sand remains the same no matter what room we go to. Okay. And then inside here, this is the sort of tricky bit, is we need to figure out if you hit this and there's an exit, then you can go through that exit and end up in the antechamber. We also need to make sure we've got walls here as well. So right now there's nothing stopping us going off here because it doesn't do anything. Okay, making good progress. I hope this video is helpful. It's amazing how quickly you can knock some of these things up. Okay, right, let's get this one done here. So we need to draw our walls vertically as well. So if we have vertical walls, that means we basically draw those end caps there. So let's do that just now. So where's our draw walls? Renderer, okay. Draw wall is top, okay. So we need to have private void draw side wall, goal is left. So I want to say for int x equal int y equals 0, y less than 12, y plus plus, and then SpriteSheet dot draw sprite batch new vector 2, and then it's going to be is left 0, and then actually let's do float offset equals is left 0, otherwise it is 15 times 16, and then int wall equals is left sprites wall left sprites dot wall right. So we're doing offset y times 16, and then cell ID is going to be wall, like that. So we can draw sand, and then we say if description dot wall west, draw wall, side wall, true. If description dot wall east, draw side wall, false. Okay, so we get into here. Go to the next one. It should draw a side wall on the right hand side. It didn't. No. Where's room description? Game map. East of first room. Oh, let's do wall east. Do you know what? I don't think we need wall east, wall whatever it is. I think we just need exit, because if there is a wall north, we've got that door thing, and if there's a wall south, then we've got that other thing, and then we can just fake it for the rest of this stuff. I feel like this might actually be double entry that we're doing. See how it goes. Okay, so that one's blocking that off, so hopefully that should stop. Nope, does not. So we need to sort that one out. So if so, is it 14? 14. Let's try that. Do 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 do. Do 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 do. So it still works. And then boom, there we go. Okay, so there's our little player, and can't move into there. All right, that's perfect. And the nice thing is we can change it to any critter that we want. So we just go into here and say the same sprite. We can do night, like that. And there you go. It's a little knight. Perfect. Even of a boy as well. There you go. There we go. Or that might actually be a chimp. Who knows? I'm going to leave it as a wizard. I think the wizard looks better. Kind of stands out a little bit against there, and also because his gown there, it kind of looks like he floats, so that's kind of good as well. So again, I just want to reiterate, all of this is in code. There's no map editor or anything like that. Everything's just held inside. I've got my sprite sheet, quote unquote, inside here, and it's just based on index values of these various creatures, of these various sprite cells. I use this SpriteSheet class that I just created, and the room descriptor describes every single room, and then our game map just contains the list of rooms, and I'm just going to map them to those values, and that's going to be it. I don't need any additional files. The only thing I need is a SpriteSheet, and everything just works. So yeah, pretty cool. Right, so the tricky bit here is allowing the player to go down here. So what I want to check is, where's our game one? Nope, not that one. I want the renderer. Where's my renderer? Here we go. So it's 7 and 8. 7 and 8. Okay. And then for our, did I do this right in here in game map? Yeah, wall north is true, wall south is true, exit north is 1. Oh, and I need wall east is true, wall west is true. For the sword dragon chamber, so this is the chamber where you get the sword. And once you get the sword, you can then wield it. Okay. Right, that's that done. So 7 and 8. 7 and 8. Okay. Where are we? Okay, here we go. So this is inside here. So if we get a wall north and we butt up against it, then we don't want to challenge it. So we also want to make sure that they're within those two values. And if they are, then we want to check. So we want to see if the player is outside that. So if current room dot exit north is greater than 0, and player dot be new position new pause dot x is greater than or equal to greater than 7 times 16, and new pause dot x is less than or less than 9 times 16, because it's got to fit that in there. So it's not all of that. Do that. And then it's got to be the same for the south one as well, because the south one's the only one we've got. Okay. So it goes to south. Right, so that doesn't work there. But if we go to here, it should block me here, but it should let me go down here. And it is letting me go down here. You know what? I'm okay with it popping up like that. You can't really break it. But the problem is it's only when you get past that point. So maybe I need to stop cancel the X and Y at that point if you're below that a certain threshold, maybe. I'm not worried too much about that. I just want to make sure that the exit works, and it does. So I'm okay with that. All right. So I want to check to see if new pause dot y is greater than, and then it's going to be 192 minus about 8. So that is 190, 184. And current room dot exit south is greater than 0. We want to change the room. So we want to change room to be that, and we want to say the new X position is going to be the same, but the new Y position is going to be 16. Exit south. Okay. So we go into here. Go down there, and then we jump into here. Boom. Would you look at that? Can we go back up? No, because I haven't put the code in there yet. But we're in here. This is us. We're in the lion's den. It's letting us go there. It won't let us go there. That's good. Okay. Sweet. Okay. So now I've got to say else if new pause.y is greater than 8. Oh, sorry, less than 8. And current room dot exit north is greater than 0. New position equals 192 minus 16, whatever that is. Well, we can work it out. It's 82, and then 6 after that is 76. Exit north. All right. So now we got our little figure here. And we go down here. Boom. And back up again. It goes a bit down too far, to be honest, but he exits properly there. Yeah, it's got to be further up than that. So it's got to be another 16. So when he comes out exit north, that's got to be 160. And then that's got to be less than that. So that's going to be 180. The kind of tweaky value-y type things, that's okay. Okay, so we get into here. Yeah, still not quite. So he's a bit, so that's fine, like that value there, but it's got to be closer to there, so it's got to be more, yeah, okay. So it's got to be 60 minus 16, so it's 190, it's got to be 176, yeah, it's 176, which is the bottom one of that, which is, yeah, that makes sense. So we go down here, and then we hit send here. Okay, that's still not quite. Yeah, he's still. Okay, well 160 is. So that's not. Okay, let's check this again. Okay, he's getting to that point and then he doesn't go. See, pardon me, I don't want him to go beyond that mantle. And he's not doing that, that's fine. So that's good. And again, the randomness of the sand really sells this, I think. And it's not really random, it's a seeded value, but every room looks different. So that's kind of neat. Yeah, all right. What else do we need here? I guess we need our sort of our object values. So we need to know the sword and whatever. What do we have here? We do have a sword. We've got this sword here. We'll get an axe as well. And we need our ghost or lobster thing, which I think we'll probably end up using as the dragon. So if I go to game 1 and then change that to lobster. Okay, there's our little lobster. So we'll make that lobster the actual dragon. So the dragon will live in here. Now the dragon, it actually just follows the player. It doesn't have any collision detection whatsoever. It just follows. So it just will go through walls and whatever to get to the player, which is kind of cool because we don't need to worry about any problems with collision detection or anything. All right, let's see if we can get the sword into the game. Okay, let's have an object or carryable object. Inventory item, let's call it that. Vector 2 is carried. Sorry, vector 2 is carried. Position, get, set. Let's just have it as that. Public bool is held. Actually, I said it is equipped. That was weird. It's like it knows. It's like it knows you're making a game. I can't get over that. And then public int current room equals -1. Okay. And then we'll have a list of inventory items that we pass in to the renderer. So it just needs to know the list. So if I go to inside here, oh yeah, I need to know the shape. Okay. I think I need to know the name of it as well, so I think I'm going to make it a dictionary. Private dictionary string inventory item inventory. Okay. And then inside here, there's new that, and then inventory dot add sword new inventory item, and then current room is going to be the dragon's room, which is number 2. Shape is sprites.sword. Position equals new vector 2, and it's somewhere on the left hand side of the screen. So it's going to be, I think it's like halfway down. So it's going to be probably 32 in, and then 88 would put it in the middle of the screen. Okay, so that's our inventory item. Then we're going to add more inventory items. Oh, it's not held, is held, is equipped, equals false. So it's not equipped. And then we need to set the inventory items as well. Actually, let's do that there, and then we can pass in the inventory items into here. So we'll do that. String inventory item inventory and then that equals that, and then generate read-only field, because we don't want to change that dictionary. It's always going to be set there, and then we need to we don't know the room number. That's the problem. We don't know the room number. So I think we need to pass in the room number to this. Int room ID. Room ID equals room ID. And then generate field. And then whatever we call this. We only call it in a couple of places. Set descriptor current room. So that's going to be 0. And then the other one is we set it inside there. So we're going to do int room ID. And we set that to room ID. And then where do we need to change these? Oh, there's a couple in here. But they're okay, because I can put that in here. That one there. That one there. And then down here. Oh, it's very clever. Very, very clever. Okay, so all of that's done. So now when we go to our renderer, what we want to do is we want to draw walls, and then we want to draw that. We then want to say inventory dot select item, where item dot value dot isn't equipped, and I dot value dot current room equals room ID. Dot for can I map that? No, I can't. I thought I could, transform that. That's annoying. Take. No. I wonder if it, sorry, I'm trying to figure it. I'll just do toList. Items equals that, okay. That's not right. No, that's not right. Wait a minute. Wait. If turn I dot wait, what? No. I want to go through every, so select. No, you put the criteria in, don't you? Projects each element of a sequence into a new form. Shoot, where? Okay, and then we want to do dot select I to I dot value dot toList. Okay, that's okay. Sorry, brain was going crazy there. And then for each var item in items, SpriteSheet.draw, and then we want to draw our SpriteSheet.draw sprite batch item.position item.shape. Okay, so what what am I doing? What I'm saying is take all the items in the inventory, and if it's not equipped and it's in the current room, then you want to draw it. Okay. Equipped items, they're going to be rendered slightly differently, but unequipped items, they're going to be rendered that way. Oh yeah, change it to a sword, that's why. Let's go back to game. I was testing. I was making sure it was working. So the nice thing is you can just, as we did earlier, we can just change that to wizard. Okay, so now our wizard's back. So we go back to here, and down to here, and then down into here. Here's our sword, and we should be able to pick it up. That's our next step. So we pick it up there. And oh, we need to, yeah, we need to make sure that's in front of, like, that's a background image. So, I'm okay with that just now. Right, so the next thing is we have our inventory items there. We want to see if the player has touched the inventory item. So that goes to game. Where are we? Inside our game. What am I missing? Oh, game's here. I'm in the class, that's why I'm missing it. Alright, so all of this is crazy town here. So I think what I mean, to clean it up, what I could do is I could just, yeah, I can get that to be get player input, and then that would be private vector to get player input. That there. And do vector 2 offset equals vector 2.0. Return offset, and it just kind of tidies it up a little bit. So instead of that, we can then just have that, and that gives you a new position. And then from our new position, we can then clamp that position. So X, and then we can do new position equals check collisions, new position, and then do private vector 2 check collisions, vector 2 new position, and all of that is new position, so let's do that. And then let's do return new pause. I'm just going to do that there. And then we can just do player position equals that. Okay, and then that tidies up the update. And hopefully doesn't break anything in the process, but that should be good. And then we should be able to go down here. There we go. And we should be able to pick up our sword now. That'll be the next thing to check. Okay. Check collisions. Let's change that to check screen bounds, because we also want to do check object collisions. And then we're going to have private void check object collisions to position. So check current room objects. So we're going to say inventory dot where not where I dot is held value dot is equipped, so where it's not equipped, and inventory dot current room. I think we need to change dot current room equals we don't store that anywhere, that's the problem. Change room, do we change that? Kind of double dipping in this. I think what we can do is we can cheat. We can just have public int room ID current room dot room ID equals room ID, which is going to get set to the correct value anyway. He said trying to avoid a hack, which it already is. And then current room equals current room dot room ID dot select I to I value dot to list var items equals that. And we can say for each item in items I think rectangle's got collision, so rectangle player equals new rectangle, and it's going to be position comma 16 by 16. Oh, it doesn't have it, really? Dot x pos dot y. Oh, come on. You're going to make me do this? Let me create a add new item vector to extensions. Rectangle to rectangle this vector to position comma int cell width equals 16 int sprite height equals 16 sprite width new rectangle position dot x comma position dot y sprite width sprite height. And then inside here, we can just do rectangle player equals player dot position dot to rectangle, and then rectangle item rect, let's call it rect, equals item dot position dot to rectangle, because they're both 16, and then we can say if player rect dot intersects item rect okay, and I'm only putting that there because I want to set a breakpoint if it hits. Okay. I mean, we could set this to be the first screen, but never mind. So if we hit this sword, it hits it, which is perfect. Okay. So if it intersects it, what we're going to do is you can only hold one item at a time. So the current item is going to be whatever that current item is. So we're going to have private item, inventory item, current item. We're going to say current item equals item. Current item dot is equipped equals true. And if it is equipped, we need to do something about it. Actually, the player has to have that current item because we need to be able to draw it public. Inventory item get set. Tidy that up as well. So inner, where are we down here? So instead of current item that, we're going to have player dot current item equals item, player dot current item dot equipped is that, and we can get rid of our current item. We don't need that there anymore. All right, now we've got that. We set it to be that, and now that we have our current item, we're going to equip it to the player's right hand side. So for the sword, I think as well for the sprite sheet we need to know, for sprites we need to know if we have to invert it or not. We don't know that yet, but we do know it if it's in the inventory item. So we want to rotate it 90 degrees. There's an easy way to do this and there's a hard way to do this. I'm going to choose the easy way, and the easy way is I'm going to edit this file, and that's going to be the easy way. So give me 1 second and I'll be right back. Oh no, I recorded a whole bunch of stuff there and I can't remember what it was I recorded, so I apologize. I added the ability to drop the sword. I'm not sure if I added the ability to pick it up or not. If that recorded, 1 second. Okay, good news is it didn't. That bit did record. Okay, so yeah, I added the ability to drop the weapon. So you can press the space bar. If you have a current item, then it sets the equipped state to false. It sets the current item's room ID to be whatever room you're in just now, and it sets the position to be the current player position plus a little offset, and it also sets the current item, it resets the current item to null. So it means that when we go into pick up the sword from down here, we can pick up the sword. So that's us picked up the sword. We can dump it, and when we come back, it remembers where it is. And similarly, if we dump it here and go through to this room, it remembers where it is. And if you're quick, you can dump it just before you get into this room, and then when you go back, you immediately pick it up, which is kind of cool. So everything works so far. The only thing that needs to get done is the rest of the rooms. I think I'll go ahead and do that myself. So the next time you see this project, I will have all the rooms in. There's no point in, I mean, it's fairly rinse and repeat for what we have here. But when I do come back, we're going to have our first baddie, which is going to be the big giant dragon that lives inside here. So that you have to grab the sword and then kill the dragon. So it's not going to be a massive dragon. It's basically going to be that lobster or something like that. Maybe the ghost or something. It might be even better. But it's just going to be a slightly bigger sprite than this one, than the wizard sprite, and it won't look like a duck like the original one. But yeah, I think that's good enough to get on with, and I'll catch you in the next video. Thanks now. Bye bye.